Okay, guys. Good evening. So today we are here on an IBM data science session. So the first question would be: how many of you are familiar with data science? How many of you are already working in the field of data science or ever used it before? Okay, so to just brief it down, we are going to start with what are the basics of data science and how does this data science experience actually work. So first, to get started, here are the quick takeaways that we'll be having for today's session. So first thing would be we'll be having a quick tour around the IBM DSX platform, which is the latest version of our data science offering that lets us run Jupyter notebooks on the cloud itself. So then we'll just go through what basic classification and regression are, and then get started with something called the iris dataset, which is the primal dataset for most of the problems. And then we'll also try to get into MNIST dataset and accessing files from DSX storage and other things, right? So before we get started, I'll just quickly go through what actually Jupyter notebooks, what actually DSX is. So for that, uh, I hope all of you have your IBM Bluemix accounts. If not, just make your account at bluemix.net. So quickly just register with the following domain. So quickly just register in the following domain. I'll just paste the link to this domain in the chat. So that's where you could register for your Bluemix accounts and also create your IBM ID in the parallel. Right. So once you're done, you're supposed to navigate to datascience.ibm.com. This is where we'll be starting with our entire DSX experience platform. So I'll also put the link to this particular domain in the chat itself, or you could just Google for data science IBM, right? So here we are. We just, if you're a new user, you need to click on sign up and create your account. But I'm going to quickly go through the signing in process. I'll just sign in with my ID. So once you log in, this is the dashboard you're going to see. So I'll just give you a 1 minute before you're done with creating your IBM IDs and start creating your environment. So let's just take 1 minute and have a brief break. Or you could just complete with creating your IBM IDs and creating your default projects in IBM Data Science Experience. Meanwhile, let me just go through the presentation once more. Okay. So usually what is classification, right? Most of the thing is usually data science refers to the ability of a person or an algorithm to collect data and get valuable insights from our data, and to make sure we have the answers for whatever the things that we need. For example, if we're trying to predict something, we could do that using our previously available data. So something of that sort. So first thing would be classification. Usually what classification is, like the name itself says, for example, we have a data set in which if you could see the following figure, there are a multiple number of axes and there are multiple circles, right? So when I try to just divide between these two things, it's called a classification problem. When I want to divide, and what happens is whenever I get a new set of data, I need to know which class that particular set belongs to. Is it a cross or is it a circle? That's how usually classification problems come under. So one of the best examples would be like classifying if it's a human or it's a dog, right? So you can also consider dogs and cats. For example, if you have a data set of 10,000 dogs and another data set of 8,000 cats, so when you get a new image or new data set that asks you if this is a dog or a cat, in that particular case, you'll be going with the classification problem. In the classification problem, you're actually trying to classify an object basing on the previous data set you already have, right? So if you see the basic applications of classification, you could go with the basic spam filtering that Gmail and other mail providers currently does, right? So once you get a mail, previously what used to happen is we used to get all the mail and we need to read them and other stuff. But nowadays it's getting pretty smart and it's classifying the mail basing on the tags. It's identifying spams for you. It's actually identifying things that need to be in your primary outbox, and you have the social outbox now. So all those things. And also you have recommender systems. You recommender systems are something like you have YouTube, right? In YouTube, if you are watching a video, you'll be recommended that this is probably the next video you would like to watch, something of that sort. So email sorting, letter sorting, all these things come under classification, because classification is where we are actually trying to segregate and know if data belongs to which data set, right? So if you have any questions, you could just quickly ask in the chat box. Any questions on what classification stands for? Right. So clustering as well. No, Harun, clustering actually comes under a different type of learning. So we are not going to clustering and other stuff today, because this is a very brief introduction. But clustering is an expansion of the classification problem. So yes. Okay, let me just quickly proceed to the next part. So usually what happens is in classification, you have a prior data set available for you, and you'll be making some, say there's a black box in the center, right? So for that black box, you'll be sending that data available with you. And next thing you'll be doing is asking it a question that what does the future data set or something that it doesn't know represent, right? So we'll quickly go through that. So similarly, if we continue with the same flow, there's one more set of problems called regression. Regression is in when you have the actual data set and you're trying to predict some value from the future, right? So it's basically like a usual curve fitting problem, right? In which you would learn in mathematical methods. You have an entire data set. You'll try to create an equation for a curve that fits that particular data set. And whenever a new data set or new data point comes in, you just try to plot that thing on the curve and see where that thing actually leads us, right? So that's how you, if there's a new data set saying 4150, I could actually point that here, and that would reflect that data point could actually give me a result of somewhere between 7.6 and 8, right? So that's how usually regression works. So regression is mostly used for predicting stock prices, real estate prices, and mostly predicting weather nowadays, right? And also it's also used in the bucketing system for the airline travels, right? So the price keeps varying based on the customer flow and the urgency of the flight. So to just get these two things clarified, classification usually gives labels to whatever the input you're asking to, and regression gives you a value to the question that you're asking to. So if you guys are just, do you need any more clarification on what a classification and regression actually stand for? Just write it down in the questions, and we'll get it clarified. Logistic regression was classification. So like always, regression and classification are used for two purposes. Classification is to classify a certain data point, and regression is to predict something based on one of the values. And when you take logistic regression, it's a kind of regression. So all these things, base class is a regression. So we'll get into what you could actually go into what different types of regressions mean and other stuff, but we'll get there shortly. So any other questions onto what we are actually trying to do? right? So let's just quickly jump to our actual problem. Yeah. So I hope you all registered in your data science experience and just logged in. So it'll ask you to create an environment. So you could quickly create a new project, right? And a project is where you have all your data sets shared between the entire thing. So let's just say I create a project saying HackerEarth, right? And I'll just leave the description, and you see it's a DSX Spark instance and it's a Swift API. I just click create. So let me just wait till the project completes creation. Okay, so now we are done. Here we have our project created, and in the projects we are supposed to add notebooks. So what usually happens is Python is an interpreter based language, so that you could execute parts of the code and you don't have to worry about how they influence the rest of the code. So in languages like Java and C, it's a compiler based language, so you can't execute bits of code. You need to execute the complete code in one go. But in Python, you don't have to do that. So you could run only individual modules of your code. So leveraging that feature of Python, something called a Jupyter notebook has been created. Notebooks are easiest ways to present and give your code in a more formatted way. So let's just quickly add a notebook. I click on add notebooks and I create a notebook from blank. I'll say hello world. Yeah, I'll just leave the description and language. I'll choose as Python 2 and Spark version as 2.0. You could also go with the Python 3.5 if you're comfortable with that. So I'll just hit create notebook and I'll be quickly taken to my new notebook. Recommendation systems are classification systems based on your viewing preferences, and curve fitting is how do I say this? So for curve fitting, you have a set of data points and you actually try to create a curve that follows most of those data points so that you have a new equation for the curve. So for example, if I say y is equals to mx plus b, and you initially you have all the data of y and x, so you could be finding m and b, right? So once you're done finding m and b for a valid number of set of data points, from the next future value, if I ask you the value of y by giving the value of x, you could actually predict by putting the value of x in the place of the previous equation that we obtained. So that's how usually curve fitting works. You try to fit a curve in number of data points, and using the equation of that curve, you try to predict what a future data point might actually be. Okay, going on. So I hope you're familiar with Python. So in Python, this is how we actually write a hello statement, right? So once I'm done, I'll just click on the top play button here. So if you could see, that particular play button is executing this one line of code right now, right? So like this, I could be executing a block of code immediately without waiting for the next block. So to go around with the environment of it, you have this option called kernel, in which you could actually change your kernel any point of time. So currently, if you could see, I'm running it on Python 2 and Spark 2. So if I want to change this kernel to Python 3.5 and Spark 2.5, I could just click on it and it starts, right? So now my code is actually running in a Python 3.5 environment with Spark 2.1, right? It's connected and trusted, it's done. So I could, every time you change a kernel, all your values would be refreshed. So I just print hello world again. So similar to that, right? You could keep changing, this is how you change your kernel. And when it comes to DSX, you have some pre-built libraries already installed for you for ease of access in data science. So if you could see the info tab on the top, the I, you could click it, and here you change your notebook's name and other stuff. But if you go to the environments tab, you could actually see a brief history of what are the things that are available for you, right? So it'll also be listing the, for some of you, it'll also be listing the number of pre-installed directories and libraries that are already present. So quickly, let's get back to HackerEarth. So previously, and right, so I'll just share an URL with you. So guys, if you could quickly open this URL up, this would be the entire URL we'll be following. All the files that we'll be following today is given in the URL. So I suggest you quickly open it up in a new tab. The capacity that depends on the usage. So for this is a light usage, so you don't even have to worry about running out of capacity as of now. So if you could quickly go take a look at the GitHub repo available for you. It consists all the data files that we're going to use and all the Python notebook files that we're going to use today. And there's a note that says you just need to install scikit-learn 0.8 version and all those things. You could just give it a reading and you'll come to know what we're actually doing for today. So let me quickly start with a demo. So I'll just click on add notebooks. I select from URL. So what I'm trying to do here is I'm trying to quickly import a classification problem, right? So if you could open the classification 12-liner code, this is what you'll be seeing. I'll copy the URL of the code, paste the notebook URL here. Yes, and I'll give this a name, right? And I click create notebook. So this is now DSX actually imports that entire GitHub notebook onto our platform and creates our executable file for us. And you need to be careful because you need to select the path of the Python notebook, not the directory itself, right? So do you have any questions still here on how to create a notebook or something? I hope everyone's following. If you have any questions, you could just type in the chat box. So how many of you are done creating your data science accounts? If you're done creating your data science account, just leave a 1 in the chat box. And if you're not, just leave a 0. I need to see ones. Joshi, I think you should actually speed up. So just create an account in IBM DSX and you could actually go through creating a blank file and see how it actually works. Then you could copy this URL from the data science experience, the notebook URL. So once you're done copying the notebook's URL, you paste it in the URL tab and you give your URL a name. Then it starts creating our notebook based on the GitHub repo. Right. So this is how our actual 12-liner code looks like. So in the top, if you could see, we've actually we actually did something called exclamation pip install scikit-learn is equals to 0.18. So what this actually means is usually this pip is the Python package manager that lets us import or install the required modules for our Python development. what happens is in the basic, it's 3.5. So what happens is our DSX by default comes with some libraries installed. But if you want any specific library or any specific version of any module, you could directly install it using pip. So you could install OpenCV and all other things needed for your development. So the exclamation in front of pip actually tells the compiler or interpreter that this particular command is not to be executed as a Python script, but it is a shell script. So once I just hit on executing the first line, it says that requirement has been satisfied, because in my particular notebook environment, scikit-learn 0.18 has been already installed. But if you're trying in a fresh environment, it will be downloaded and installed for you. So just follow up, guys. I want you to install the first line, to run the first line and install scikit-learn 0.18, because the older packages would give you an error in the things that were continuing for. So yes, so and once again, if you could see this thing, all this code has been tested on a Python 2 environment, right? So tested on a Python 2.7 environment with Spark 2. So if you want, you could change the kernel here, like we already discussed, change kernel to Python 2 with Spark 2.0, right? So the kernel now updates and immediately starts running Python 2 instead of Python 3. That's how you switch between kernels, right? So, yep. So the next part, import pandas. If you could see, we actually divided the entire code. So this part first cell is actually importing the required libraries and modules for us. Here we're importing pandas. Pandas is a data frame object of data frame library, which is very helpful when you're trying to read objects from a file and process them in Datascience. So, and the next library would be k-neighbors classifier. So that's one of the types of classifiers we actually see. So before we get to that, here is the data we are actually trying to, you could copy that URL and paste it in your browser, and you'll be seeing the data set that we're actually trying to classify, right? So here, if you see, I'll just go briefly about the data set, right? So in the first example, the first notifier we are trying to do is, we have a set of measurements for each of these flowers. If you could see, this particular part of a flower is called a sepal and the top one is called a petal, right? So the widths and lengths of each of these components would actually determine which family that flower actually belongs to. So the same flower, iris, has three subclasses. It is iris versicolor, iris setosa, and iris virginica, right? So what we are trying to do is, we'll be given a set of data packs for the set of data points for the versicle family, and another set of data points for setosa family, and another set of data points for virginica. So we are going to create a classifier that actually takes this input and tries to classify any new flower that comes in, right? So this is how our actual data set looks like. If you could see, the first one is the sepal width, next one the sepal height, and following is petal width and petal height, and this would be the class of our flower, right? So this is the actual data set we are looking at, that we will be using for training. And if you could see, there's we have around 50 data points for iris setosa, and we have 50 for iris versicolor and another 50 for iris virginica. This is not a regression problem, Suresh. We are actually going with a classification problem. Python Studio from the project. You don't get to use Python Studio. This is a Jupyter notebook. So you just create your notebook and you start running your code on the go in DSX, right? So yeah, so the first part, we installed the scikit-learn 0.18 library that we need, and then we actually imported the libraries that we would be needing. And in the third part, you'll see that this particular URL has reference to the data set, and we'll be creating an array that contains the names or the top titles for this data set, right? So if you could see, sepal length refers to this, the first measurement, and you have the sepal width representing the second measurement, which is 2.0 in this particular case, right? So similarly, we have petal length and petal width, and this is the class, right? That's how we divided our data set. So we are actually, in this line, we are actually trying to read the entire data set into a pandas data frame object using pandas read CSV function. So after we are done with that, we just import all those values into an array, right? Here in this part. And in an array, the things we are trying to classify is, if you could look, if you consider this as a basic linear classification problem, we have y is equals to mx plus b, in which x is an array of all these things, the measurements, and y is the class name, right? So that's what we are actually trying to do here. Put the values starting from 0 to 4 into x, and the values values in the fourth last column into y, right? So after we are done, usually sklearn implements this method in which any classifier or classifier usually has a fit method which takes the parameters, that is x and y, right? That is the training labels and training data set. So after it takes it, it creates the classifier basing on that data set we sent, and then it implements the predict method in which we could send in a query, which is the x points, and it will actually predict the class of the data set, right? So let's quickly run through this. I've imported my libraries. I've read the data set, created the array, and called the classifier. And the classifier actually created a classifier and also had the values. And I'll just quickly print predictions, right? In predictions, I've just sent in some values, and these values actually represent the class label for iris versicolor. You could refer them here. For example, if I take some values from iris virginica, right? So they actually are varying from 6.5. If I just copy this, right? One of the predicted value, I could replace it here. Sorry. I could replace that instead of the old values, and I click play. And again, it predicted that it is iris virginica, which is actually true, right? So this is how the usual classifiers work. You create the data set, you create the data set, you train the classifier on the data set, and you start predicting using that particular data set. So any doubts till here? Any quick questions? You want to get original image using iris dataset? Definitely, Srikanth. So let's, I hope, let's quickly jump to the other part. In you could see another file called classification simple, right? So copy the URL of that file, go back to our project, which is HackerEarth. You create a new notebook, and if you could see this particular notebook, DSX classification simple, actually does a lot of things and also gets us the images as well. So let me quickly use that file. I click on add notebook from URL, classification with image, right? That's what we actually wanted. Paste the URL in this particular field and click create notebook. So now our notebook is ready for execution. So similarly, I just import the required libraries, and also I imported something called IPython display, This is a particular library that we are going to need if we want to display inline images in our code using Jupyter notebooks, right? So similarly, this block remains the same. And this particular block, if you just print dataset.h, in dataset, we actually contain this particular dataset. The entire CSV file has been read as a pandas data frame object in dataset. So what print the dataset, you can give the name of the dataset. Head is actually a pandas data frame function. What it does is it prints the first n number of values in that particular dataset. If I say print dataset of 150, right? Dataset.head of 150. If I print it, you'll be able to see that it gets the first 150 values out. It's a bit slow, I guess. Just give me a second, guys. Kernel has been disconnected. I'll try to refresh the page. Right, so kernel is still starting. Yeah, now we have it ready. So if I quickly run through it, if you could see the asterisk on the side, the asterisk actually means that that particular cell is under execution. So if I print dataset.head 150, I'll be able to see the first 150 values from our dataset. This is very useful when you're actually trying to take a look at what this dataset actually represents. So if I print 17, I'll be able to see the first 17 values, right? So as it is starting from zero, it will just show 16, right? So the next part is dataset.group by. In this particular case, these are the class names, right? Sepal, these are the class names, Iris setosa, and you have, let me just print the next part. I'll just say 150. I'll print all the data set. So these are the class names, Iris setosa, Iris virginica, and you have one more class in between, which is Iris versicolor. So I just want to see what classes are in the data set. So I just print this part, print dataset.group by class, and I'll print also the size of the data set. So if I print that, you'll be able to see that there are 50 items in Iris setosa class and 50 more in versicolor and 15 virginica, right? So these are some of the functions that are quite useful when we're going in the fly to using DSX. So the next part is I'll just create a quick function that sets the source of image for me. And if you could see, I just made an array here. That array contains the URLs of some of the images. If I just copy this particular URL and paste it somewhere here, right? You'll be able to see that it's showing me an image, right? So similarly, the other two URLs contains other flowers. So, and this particular function, this is how we define functions in Python. Use the def keyword. So you created a flower array, which is actually taking the flower list, and a simple if else ladder, which creates, which sets the source of the image file basing on the output of our required function, right? So I execute it, and this part is same as the previous thing again. So we are actually trying to be we are actually trying to get the data set into separate arrays of X and Y, right? And then we are using the classifier fit function to call it and create a new fitted database. Now we have the image prediction, right? Once you call the prediction, it actually predicts the image. And the next part is the source of the image has been set using source setter function, right? So here you could actually see that whenever the prediction is done, we are passing the prediction value to this function, and this function is setting the source of our image accordingly from the available data set. So it's similar to that, right? This is how you get images of your data set along with your for example, if I set this to iris versicolor, right? Okay, it's already iris versicolor, so let me just try iris setosa, and I just set it here, and I run this particular block, and I'll be seeing the image of iris setosa, right? So any other doubts? Any clarifications on to how we got the images and other stuff? Right. So similarly, we also have other classifiers like Gaussian base, naive Gaussian base, and other stuff. So the process remains same. You just import that particular classifier from the naive base library. You create an object basing on the imported classifier, and you call the fit function sending in the x and y parameters, and then you use the predict function call to actually predict what's in that classifier. Yeah. Okay, so that's about the basic classification, and let's quickly jump on to the next part. So guys, any doubts in classification, how we got things done? There's one more file if you want to just go through everything, what actually are available in classifiers. There's a classification evaluation file, in which you could actually see the actual results of the entire data set, how we evaluate the data set, how we part it, okay, all those things. Enable voice, you can't actually enable voice, Purushottam, so you just need to type it, right? So if you could see here, I'll just quickly import this part as well. So in here, we are actually trying to create a new notebook. Add a new notebook from URL. And I just paste the URL of the notebook, and I click create notebook, right? So this is how you actually import your entire notebook onto your DSX platform and start working with it immediately. Right, so I just imported the entire notebook. So if you could see, this is the first line. We are just checking the available libraries, right? So if you could just quickly hit play, you'll be given the list of the available libraries in your environment, right? So chart window, I think you'll be able to see it to the side, Karthik. So that's how you check what are the available libraries in your DSX platform. The next part would be importing the required classifiers. So if you could see, we've imported pandas and scattering matrix, and matplotlib is what we'll be using to actually plot our data set. So the next part is we import all the required classifiers, right? The syntax is similar. You just import sklearn dot that classifier, particular classifier's name, right? So let me just run this part as well. And the next part, we're actually creating the labels for our data set here, names, and importing the entire data set. So once we are done, you could actually print the dataset.shape. It gives you the dimensions of your data set, which is 150 by 5. If you could see, there are 5 rows and 150 columns. So execute that as well. And the next part, you're printing dataset.head, which we already discussed. Will show you the first 5 available data points. And next, there's a very quick good option called dataset.describe. that actually goes through the entire data set and gives us the basic insights on our data set. That can be the, you could see there's a mean and there's a standard, the minimum and the maximum. These are the data points that actually are calculated dynamically along with the data set. So a count gives us the total number of things. And then you go with group by, which we already saw. We are actually trying to group the entire thing. And then you're visualizing the data set in various kinds of plots, right? Like there's this box plots, and then we have histograms, and we have scattered matrices. So the main point of this particular notebook is to demonstrate that it is quite flexible when coming to visualizing the data we have, and it is really, really powerful onto how quick these things can be done, right? So the one best part is usually what happens in data science is, first you actually get the data set, the entire data set, you label it, and then you're supposed to segregate the data set into a training set and a testing set, right? So for example, say I have 100 data points. What I'll be doing is I'll divide 80 of them into one array and the rest 20 into other, because I want to actually train my system on these 80 points and use the rest of the 20 points to test its accuracy, because I also already know the labels of the testing set as well. So I'll be knowing if the system is giving me right answer or not, right? So that is the reason we actually divide the entire data set into training and testing sets. So any doubts regarding that? So why do we have to actually divide into a training and a testing set? Right. So that's what we actually done in here. So here we actually have a set of values, which is x train and x validate and y train and y validate, which actually says that I'm using the x train and y train values to actually train the algorithm, and x validation and y validation to test if my algorithm is giving me the right answers or not, right? So that's how I've divided my entire data set. And seed is, how many of you are familiar with random numbers in Python? How many of you are familiar with what seeding actually does? And it ones and zeros. If you are good with screen is hanging while audio is fine, whatever. I think it's a problem with your bandwidth, Uday Sai. So okay, so what happens is, when I'm actually giving a basic demo or something, when I'm demonstrating something and I want to generate a set of random numbers, right? So if I say I pick I want to generate a random numbers between 1 to 100, and the random numbers I've actually generated are like 4, 5, 9, and 13, right? When someone else is trying the same, or when I'm trying the same thing again, I need the same set of random numbers, 4, 9, 5, and 13. I don't want a different set of random numbers each time, right? So for that purpose, there's something called seeding, in which when you seed a random generator, it generates the same set of data for a seed. So no matter how many times I seed a random generator with 7, it's going to generate me the same number and same set. So that's how usually seeding is used. So I'll seed it with some value called 7. And if you could see, here I'm actually creating an entire set of all the models that I've imported, the basic classification models, that is logistic regression, linear discrimination, KNN, all those things, right? So I'm importing all those. I'm training all of the algorithms on the same X-trained data set, and I'm trying to evaluate, right? So if you could see, cross selection score gives me that. So I'm also trying to evaluate the accuracy of that particular algorithm based on the training validation set, right? So if I run this particular block, it will show me the accuracies of various algorithms. And if you could see, SVM is most accurate, but the problem with SVM is it needs a lot of computation power. So it's always a trade-off between the right algorithm and the quickest algorithm. So you just need to make sure you get things right. So after, I could also start plotting figures. So all this capability comes by default in Python, Jupyter Notebook, so that you don't have to worry on doing intensive works. So yeah, in this particular set, if you could see, it's similar. I just created a k-nearest neighbor object, and I use the fit method to actually train that object, and then I use the predict to validate the scores and get them. So this is the total score of the prediction. That's how usually, that's what we've done for all the algorithms in this particular notebook. So you could quickly go through the notebook, and meanwhile, quickly go through the notebook and just get back to me if you have any doubts or any syntax problems, or you didn't understand any particular object, right? So meanwhile, let's just skip to the next part. So any doubts till here, guys? You need any answers regarding classification or how the actual code is being written in Python, and any syntax problems, or if you want to know anything, right? Do I proceed? Yes, Riyasha, the only thing is, like, as of now, I'll get to this particular point when we're actually running the MNIST data. So the one thing is it's universal availability, and also the power computing object you get. So yeah, I'll just explain your question in a while, right? So guys, I think I can proceed. So the next part would be regression. So in basic regression, before going to regression, we'll just quickly go through MNIST data also. So MNIST is actually a set of a database consisting more than 60,000 data sets, which has actual data, like, like 0000. A person writes, different persons write the word zero for 60,000 times. Similarly, we have different ways of writing one for those many times. So what usually happens is, when we want to recognize what a person actually need, we need to understand what he's writing and the pattern of his writing, right? So here we have this particular MNIST data set that has thousands of images of the same digit written over and over, right? So that's what we'll be using to train our next classifier. So if you could quickly borrow the MNIST simple Python notebook, copy the URL, and you know the drill. You just go back to our notebook, right? Click on add notebooks, choose from URL, and paste the URL here. Click on create notebook. So it immediately imports the entire notebook onto your DSX. Yes. So the next part is, for creating the MNIST data, you need another library called nolearn. So we'll just quickly install the nolearn library using this particular pip command, right? If I hit that, I'll see that it has been already satisfied because I've installed it already. The drill follows. You just import the required statements, and you go with importing the data set from TensorFlow. So TensorFlow is one of the best machine learning libraries currently available from Google. It has been open sourced, and so we'll be using that particular data set also. So if you could see, it quickly got images up to 60,000 images in less than 2 seconds. So that's the bandwidth you get, and that's the computation power you get. So, and to answer the previous question from someone asking why run something on a web platform when you could do it on a local PC, the difference is the computation time. If you could actually run the MNIST data set and try to train it, it'll take you nearly 40 minutes for 10 training epochs, right? So in here, you could do it under 1 minute. So if you could see, it keeps on showing the data, the verbal output of everything we do. So you could quickly run through this, and here you could see epoch is a complete repetition of the training, right? For example, when you're kids or something, if you want to learn how to write the word "a," you keep practicing, you keep writing it over and over again till it looks like something like "a," right? You write "a" again and again, keep repeating it. Then you go to the next letter and keep repeating until we get the better output. So that's what happens. Our same deep belief network will be trained on the same images over and over again for up to 10 times to increase the overall accuracy, right? So I run this particular, you could see that actual training is going on. And if you run the same training with 10 epochs on your regular PC, which comes with a standard of 8 GB RAM and a 2 GB graphic card, you would actually take more than 40 minutes to complete the training, right? So let's quickly see how much longer it takes. And meanwhile, if you have any questions, just post it in the questions column. I think I've already answered your question, Sriharsha. Right, so we're already done with 3 epochs. Watson API for creating chatbots. Srinu, this is not Watson API codes, but you could directly import Watson libraries into this and make REST API calls. So all of them is supported. So you could just install any library you want using the pip and you could start using it. So we are already done with the 7th repetition. So that's actually, if you run the same file on your local notebook, you'll know the difference between the computational needs that it actually satisfies. Right? So we are done with running 10 epochs. Now you could directly go with prediction. So what this particular line does is this particular line creates a classification report, the accuracy. It makes a self-test. It tests based on the test images and the evaluation images. It creates an accuracy report for us. So let's just wait till the execution of this particular line is complete. And then we have this function called random image. It actually picks an image from the data set that's available for, like, from out of 60,000 images, it picks an image and tries to predict what that image actually looks like, right? So let's just see once. The star in here just represents that this particular line is still being executed. So it's going through all the 60,000 images and predicting the labels and trying to see which one of them are right, right? So here you have the precision and the overall report. And now if I quickly keep running this particular cell, if I call this function, that function is going to pick a random image and try to predict what that image actually stands for, right? So DBM, I don't see DBM. Oh, okay, it's a DBN actually. So a DBN is a deep belief network. So here it creates a deep belief network. If you want to see what a deep belief network is and other stuff, I think you should just Google for them. So a deep belief network is something that has thousands of hidden layers and a functional layer in the end. So it's a complex neural net, right? The DBN function actually creates a deep learning neural net for us. So if I keep running this particular random image file, it picks an image from the data set and it tries to predict the actual digit is coming from the label we have, and the predicted digit is coming from the label that we try to run. So if you could see, it's predicting a lot of mistakes, and also some of them would be right, because the number of epochs we actually tried is 10, which is too less. So you could run it for 40 or 30 and you'll see a very improved accuracy, right? So any more doubts? Yes, Himanshu, you get a trial period of 30 days. And in case if you're still wanting to extend the trial period, you could raise a ticket and you'll be given a free access for a longer time. Okay, Suresh, minimum number of epochs required, that's again a trade-off. See, it's a trade-off between the time and the number of data point, the accuracy that you're actually wanting to. So you could increase the number of epochs to 100 or 200, but that will consume a lot of your time for training. And if you decrease the number of epochs, the accuracy also falls. So you need to get an optimal level where the accuracy is good enough and also it doesn't take too much of time. Right. Any more doubts, guys? Okay, so that's pretty much all about the classifications we are going through. And the next part would be we'll quickly go through regression problem as well. So like we already discussed, regression is something that tries to label, right? Regression is something that tries to predict a value in the future, right, from the future. So if I have a data set and I have data set, for example, when we are trying to predict weather, right? So I have the weather ratings from the past 30 days or 40 days of a place. And what I'll do is I'll use all of that to probably say what the weather might look like the next day, right? So when this particular thing happens on a data set having thousands of days, like hundreds of years, then that would get more accurate. So let's just quickly try to do one more problem here. Just go on to your GitHub repo, and in the GitHub repo, you'll be seeing something called a viewership data CSV file. So if you could see, if you could have a look at that particular data set file, I have, so there are a couple of TV series called Flash and Arrow. So here what I have is, I have the episode name and viewership for US, right? That means how many people in million have viewed that particular episode. So for example, the first episode of Flash has 4.83 million US users. So similarly, Arrow had 2.84 million users. So I have the data for the first 9 episodes. And what I want to do is I want to predict how much that the 10th episode might actually get, right? So I'll just quickly download this file, viewership data.csv, or I'll just go through the get download procedure. So you just go to the directory and you already downloaded the zip, right? Save file. So here we have our DSX file. So viewership data.csv contains the data we actually talked about, the viewership of the two series, flash and arrow in millions, right? So what I want to do is I want to predict what the viewership of 10th episode might actually be. So if you could go back and see, there's a regression TV Python notebook. Quickly click on that, copy the URL, go to our notebook project, add a new notebook from URL. I'll just say TV and paste the URL here, and I create a new notebook. So in this particular part, we'll be just seeing how to import that CSV file onto our cloud. So here we have the basic imports that are needed. And the next part is, unlike the other sources, now our data file is actually a local file that we have, that a CSV file that we have on our local PC, right? So we'll just try to import that. You could see the data option on the top, find and add data. Click on that. It asks you for file. You could just drop your, oh, sorry. You could just drop your local file in here and it will import that particular file. So once you're done importing, you just need to create an empty cell. You create an empty cell and make sure the cell is selected. Hit on insert to code and choose insert pandas data frame, right? So that then you will be seeing that DSX automatically generates some lines of code in which it actually creates a session to the storage unit and gets that particular file with the required session IDs. And if you see, this particular variable df underscore data underscore one consists our data files, right? So I'll quickly execute this and you'll see that this particular variable df underscore data underscore one is now containing the data from our CSV file. So this is how we import a local file onto our cloud, right? So I'll quickly do this thing. I'll copy this one particular line, which takes care of importing the data from a local session. And I just paste it here. This is, so in here, I'm actually trying to import that data into an object called data instead of importing into data underscore df underscore data underscore one, right? So let me just quickly execute this. So in this part, you will be seeing that we actually divided that into training and testing data set and all those things here. So if I quickly run the code, I'll be seeing that the algorithm predicts that the Flash TV show might have more number of viewers for the 10th episode, right? So it actually says Flash might get 3.95 million users for the 10th episode, basing on the previous 9 episodes, right? So this is how we quickly import our files and use local files to run our code on our DSX platform, right? So that's pretty much it. That's pretty much about what we are about to do. And so any more questions, guys, before we close off? You could go through the GitHub repo I've just shown you. So it has the documentation for everything we just did and also some additional files which you could use to further learn things. So the README provides everything you'll be needing, right? So any more questions? You could just type your questions in the chat box, or we'll be ending this in 5 minutes. Okay, guys, thank you. I think that's about it. So if you have any questions, you could reach out to me at my email ID. So I'll be showing you the email ID on the screen. So if you have any questions or further queries on DSX, you could just drop a mail to my email ID, right? So I'll leave this in the chart. No, Srini, you can also import PDFs, CSV files, and all other data files that you usually support. And there's also a conversion ability, so that so you could import any kind of files, zip files, everything. Okay, guys, thank you so much. I'll be closing now. Thank you.